लड़काए और सीटी बजाए, दिल धड़काए, सीटी बजाए, बीच सड़क पे नखरे दिखाए, सारे हो करके इशारे, हो लड़की हो लड़की ओ लड़की आंख मारे, आंख मारे, ओ लड़की आंख मारे, आंख मारे, ओ लड़की आंख मारे।
जहाँ जहाँ जाऊँ मेरे पीछे पीछे आए, गली गली के आशिक तो मेरा होना चाहे।
हाय जहाँ जहाँ जाए तेरे पीछे पीछे आए, हम तो है दीवाने तेरे, तेरा होना चाहे।
सीटी बजाए, नखरे दिखाए, सीटी बजाए, नखरे दिखाए, बीच सड़क पे हर नाम मेरा पुकारे, ओ करके इशारे, ओ लड़का, ओ लड़का, ओ लड़का।
आंख मारे, आंख मारे, ओ लड़की आंख मारे, आंख मारे, ओ लड़की आंख मारे।
तुषार कपूर की आवाज में कुमार सानू की आवाज में
ओ लड़की आंख मारे, आंख मारे, ओ लड़की आंख मारे, आंख मारे, ओ लड़की आंख मारे।
ओ लड़का,
Good morning, all. Am I audible, man?
Good morning, sir. Yes, sir.
Am I audible?
Yes, sir.
In the last class, I think we were discussing about force of tension. Okay, and we could learn that how to find the direction of tension in each situation. And before that, earlier to that, we have seen that normal reaction. I hope we have followed all this. So with this, we can go ahead. So I can put it like this to summarize that. Right. Tension force always pulls. Tension this is what we learned yesterday also, no?
Yes, sir.
You done this? Next, if a string is inextensible, what is the meaning of this? Means length remains constant. Understood this?
Yes, sir.
Okay. Then the magnitude of acceleration of any number of masses connected through the string is always same. Understood this?
Yes, sir.
Note on this. I'll explain this point with some examples so that you'll have a better idea. Suppose there is a pulley there is some rope here. Till here you followed. See here, suppose this is having an acceleration A1. Then this has to go, for example, with A2. Understood this? Now let us see. As the string length remains constant, what I do is from this fixed point, this is x2, no? See, actually, acceleration is nothing but rate of change of velocity. Velocity is nothing but rate of change of this x2, no? I am taking this as the origin. This is x1. Do you agree with this?
Yes, sir.
Yes, sir.
Now, what is the length of the string? Can you tell?
X1 plus X2.
Plus some L. What is L? Over the pulley. Do you agree with that?
Yes, sir. I agree, sir.
Yes, sir.
See, this goes like this and it's the length over the pulley, no?
Yes, sir. Yes, sir.
Now I'll differentiate this. So what you have x1 plus x2 plus L is constant. Now if I differentiate this throughout, derivative of constant is 0, no? Do you agree with this?
Yes, sir.
This is
V1
V1.
plus
Now
V2
before
plus
that, let us see. If it goes up, what happens? Can you tell? If it comes down, x1 will increase, no?
Sir.
In this case, we are seeing x1 is increasing or decreasing.
increasing.
Therefore, dx1 by dt is positive. Because x increases, no? Time always will increase. Follow what I am saying?
Yes, sir. Yes, sir.
And what is happening to x2 as it goes down, decrease or increase? Huh? Do you agree with this? Hello.
Yes, sir.
Yes, sir.
So I can say that dx2 by dt is negative. Do you agree with this?
Sir.
Yes, sir.
So dx1 by dx2 is nothing but positive. So we have plus v1. This is
Minus V2.
minus v2. This is constant.
Okay.
So v1 equals v2. You got this? Now if you
Yes, sir.
differentiate this, d1 by d2 is dv2 by dt. What does this give? Acceleration of both the blocks is same. Understood this? That is what this
Yes, sir.
statement means. Because the string length remains constant, he arrived at it. That is the reason why you are saying, if it comes by A1, this goes, you are saying, why reason is this? Understood this?
Yes, sir.
Understood, sir.
Any doubt?
No,
That's
sir.
what.
No
If
doubt, sir.
string is extensible, then minus axle. Any number of masses connected through string is always remain constant. Understood this? Clear?
Yes, sir.
Clear, sir. Clear.
Sir.
Here, turn the page.
1 minute, sir.
Shall I turn this?
1 minute, sir.
Shall I turn this?
1 minute, sir. 1 minute.
You know, you have to write the exam within another 13 months. You're aware of that?
Yes, sir.
2022 January is your exam. That means 2021 12 months. This 2020 1 month. Now December is there. 13 months. Be cautious about this. Okay.
Yes,
Yes,
sir.
sir.
Return this.
Yes, sir.
Again, don't blame. See, we have one bad habit. We have brought one concept of God actually. And for everything we say, God did not bless me. That's why I did not get a seat, all that. God always blesses, is kind enough. He'll bless everybody. Every creature in the universe is blessed by God. Only thing is, blessing means he has given all the avenues to live properly. We misuse that, we suffer. So be cautious about this. Now come back to this. That means if a string is like this is F, then what will happen? String is inextensible. So this will have acceleration A means both will have same acceleration if the string is, if follow this.
Yes, sir.
That's what we learn now. Is it visible now? Right. Now let us take the other one. We'll prove this shortly. If a string is massless, massless means assumed to be, it's not really it is possible. Okay, then tension is safe at every point. Then the tension in it is same. Everywhere, that means at every point. Okay. However, if a string has mass, and it is accelerated, then following what I am saying? Hello? Suppose you apply force F, then let us see, the string has mass, no? Then if you draw the free body diagram of string and the mass M. Now can you tell what is the direction of tension on this? This has a force F. Okay, this is tension. This is T. Do you agree with this?
Yes,
Follow
sir.
this?
Yes, sir.
Remember that
Sir.
F is not equal to T. Understood this? However, if M is there, M is not equal to 0. If M is 0, then every point, every force on the string will be same. Understood the story? Clear?
Yes, sir.
The reason for this here, you want or no need? See here,
One.
as a string is inextensible now, this is A1, this is A2, for example, we'll say. Okay, so this is A2. You know that as string is inextensible, what you have?
A1 equal to
Extensible. A1 equals A2 equals A. So for this, according to Newton law, if you write Newton's law, what will you have? M into A, no? Agreed?
Sir.
Yes, sir.
For this body, like as a string,
F equal
this
to
is for block. This is for string. What do you have? F minus T is MA. Do you agree with this? So this gives you what? T equals F minus A, no, MA. Now you can see that are they equal? Now you can see, observe this carefully. Both are tension at this,
Yes,
on
sir.
this and this are different or not? Do you agree? For example, we'll take like this only. Yeah, what is F actually? T plus MA. Now we can see from 1 and 2 what we can observe. If M is 0, F equals T. Observe this. Am I right or not?
Yes, sir.
Sir.
Is it clear? So remember that string is massless means tension will be same everywhere. Inextensible, same acceleration. Massless, same tension. Understood this?
Yes, sir.
Sir, I have a doubt.
Tell me.
Sir, in the last page.
This one.
No, sir, last page. Previous page. The diagram was there now, sir. I didn't understand how are you taking that x2 is negative here.
What?
You took x2 as negative now, sir. There. How did you get that? I didn't.
Which
I'm
one?
not getting. X2 is how
Which
x2
is
is
extra?
decreasing, sir.
Yes, man. If it goes here, what will happen to the length of the string on this side? This is coming down. This is going up. As the
For
clock
that
goes.
mass 1 should be greater than mass 2 now, sir.
No.
But that it is not given.
No, man. What I am saying
Sir,
is, if it goes up, suppose if this, otherwise this goes up, you take, you'll get the same result, man.
Yes, sir.
Understood this?
Yes, sir.
The beautiness of physics is you assume direction of acceleration anyway. After solving, suppose you get acceleration to be negative, and that means opposite to our assumption. That's so simple.
Yes, sir.
Shall I turn the page?
1 minute.
Shall I turn that?
1 minute.
Understood this?
Yes, sir. Understood.
Shall I turn?
1 minute.
1 minute, sir.
चले जब तू लटक मटक लौंडो के दिल पटक पटक सांसें जाए अटक अटक आता माझी सटक सटक बम तेरा गुते खाए कमर पे तेरी बटरफ्लाई बॉडी तेरी मक्खन जैसे खाने में बस तू बटर खाए कम ऑन बेबी किक इट काटू तेरी टिकट टिकट खेलता नहीं क्रिकेट विकेट पर ले लूं तेरी विकेट विकेट
বড় লোকের বেটি লো লম্বা লম্বা চুল এমন মাথায় বেঁধে দেব লাল গেন্দা
Wind the body.
বড় লোকের বেটি লো
Yes, sir.
লম্বা
Completed,
লম্বা
sir.
চুল এমন মাথায় বেঁধে দেব লাল গেন্দা ফুল
सांवला सा रंग तेरा बावला सा ढंग तेरा
1 minute, sir.
चोरी बातें करे अंग अंग तेरा तेरे लिए कुछ भी कर लूंगा तेरी मैं हर लूंगा कोई भी पीड़ा पागल हुआ तेरे पीछे जैसे दिमाग में कीड़ा
Sir, can you
लगे
please explain the
मीठी
second
जैसे
diagram once
शक्कर
again?
शक्कर आजा चला ले चक्कर चक्कर बाकी के
Sure.
लौंडे पकड़
This one.
The second one, sir.
Embarrass मत
Down
This
that,
one.
down that. Yes.
This one. I just drew the separate free body diagram. On this one, force is there. Tension always acts like the pulling force. I showed the tension here. That's all. By Newton's law, these forces must be equal, no? This end exerts a force on that end. That end exerts the same force, no?
Yes, sir. Yes, sir.
Don't get worried, man. Go on doing. I'm going to do. I know you cannot catch if it goes faster. I'll make you do some problem. Now I think kinematic you should be little bit comfortable. Yesterday it was a head. Fearful job. Half
Sir,
of
in
the
the
class.
second diagram, now that you explained, sir, in the second diagram, masses won't have any effect, sir.
That's why if mass is there, it is having, na, here. What I said here,
Yes, sir, if m equal to
Every
I
woman
wrote
wants
clearly, no?
beautiful brows, so we tweet.
have a free mind, man. Don't think that physics is something. Because it's part of your life. We can't do anything.
done, sir.
Shall I turn this?
Yes, sir.
Yes, sir.
Now, another thing is that, see, there is one chapter called rotational mechanics. In that, you will see actually how a pulley functions. For the time being, we require a small concept. See, suppose you are having a block like this. There is a string like this. This is hanging. Okay. Now suppose you are having this string and pulley are massless. Pulley has no mass. Okay. Pulley is not having any mass. String is also massless. Okay, there is no frictional force. Okay, these three things are there. Then, in such case, remember, string is massless, so tension is same at every point. If this is T, this is T. Agreed? This is T. This is T. Understood this? Clear?
Clear, sir.
Now the same situation, because all chapters are interconnected, no? So sometimes we should introduce some concepts here so that when we come back to the other chapter, this you will be knowing. You will understand better. Because at a time we cannot complete all chapters. This is another block. Okay. Now here string is massless. When string is massless, what you can say?
Tension is same.
Okay.
Tension will be same on the both particles.
But remember, fully is not massless. Okay. And there is friction. Understood this? Is it clear? In that case, remember that whenever there fully has mass, okay, then this tension and this tension will not be same. This and this will not be same. But because it is massless, this whole portion will have same tension. This whole portion will have same tension. But because of fully, this tension will not have same value. Understood this? Hello? See, we don't, for the time being, we don't use, we always take tension is same. But once a rigid body dynamics, rotational mechanics come, suddenly will change. The tensions are different. To avoid that confusion, now only I am presenting. Tension will be same only on some condition. Followed? Father is very good person only on some condition. Child studies properly, is disciplined out. If child is a rowdy, gunda and all, father will not be a good person. No? He will behave differently. So everything behaves in certain situations. The behavior of any object depends upon some constraint upon which it is there. Agreed or not?
Yes, sir.
So here string has mass. This is having mass. Okay. Fully has mass. Okay. There is friction between then what happens? Tension changes. Tension will not be same. Suppose this is T1. Okay. Then again this is automatically change. Point to point it changes now. This is again T3. This will be T3.
T3, T4.
Understood? Because massless, because the string is massless, point to point tension changes. Fully has mass, therefore this tension should not be equal to this tension. Understood this?
Understood,
Sir,
sir.
if particle is massless, the tension will be.
Particle has no connection. Did I use particle anywhere? Why do you unnecessarily drag this to some other concept? Particle means is mass. They speak anything, that may be anything. You may stand there, a box may be there, train may be there, irrespective of that. Particles have no role over here. I am talking only about tension in the string. How tension
Yes,
will
sir.
be. What I said is, if the rope is inextensible, all masses connected to the string will have same acceleration. First thing. Second, string is massless. At every point, tension will be different. So same. If it has mass, tension will be changed. Then about fully. That's all. These are the situations we have to come across. Understood this?
Yes, sir, understood.
Shall I turn this?
1 minute, sir.
So
1
we
minute,
have
1 minute.
seen about table can put it Hello, complete this, man.
Yes, sir.
Return this.
Yes, sir.
1 minute.
Till 1 minute. Finished?
Yes, sir.
See, the next one, nowadays the next course, I'm introducing the types of forces. See, whenever a body is there on the surface, okay, the block is not subjected to any force. Then you can see that there is a force due to electromagnetism. I told no intermolecular force is exerted. Remember this? Do you agree with this or not?
Yes, sir.
Apart from that, it is having mg. Now let us see what happens if the block is subjected to tendency to move. Tendency to move means somebody is pulling it. For example, I am applying a force here. Force tending to cause motion. Now, definitely the intermolecular forces are there, no? These intermolecular forces which are there between the surface, will they oppose or not? Because you are trying to extend this. Agreed? Hello?
Yes, sir.
So what happens? Intermolecular forces will try to oppose that or not? Agreed?
Yes, sir.
Hello? So this is again, of course, this is the weight of this. So intermolecular forces, because due to weight, the molecules get compressed. Therefore, they exert an opposite force called normal reaction. Similarly, force tries to move these molecules. So there will be another opposition force. That force is called force of friction. What is it called? Force of friction.
So,
Follow this? Clear?
yes,
So
sir.
here we have force of friction. Understood this? ఇది పడి అది బొబ్బులు ఇలాంటి one. Follow this? Hello.
Yes, sir. Yes, sir.
Can you turn this?
Sir, can you repeat?
1 minute, sir.
No man, what does see man? Intermolecular forces are there. Understand man, try to put your effort. This is the molecules, they are unstable. I told you once, when we try to disturb this by a force, what you are doing, there will be a force developed opposing that now.
Yes.
I told you in the first now, whenever molecules are in equilibrium, separation increases, what happens? There will be a force in the opposite direction. That's all. Similarly, understood it? Hello?
Yes.
This is the equilibrium separation. Now, same way, now you take like this. There is an equilibrium separation between these two also, no? Agreed?
Yes.
When a body is exerting a force mg on this, what happens? Immediately, there will be a force opposing that, no? That force only is normal reaction, no?
Yes, sir.
Followed this? Clear?
Yes, sir.
So, remember that. Shall I turn this?
1 minute, sir.
So, whenever molecules are like this, there is an equilibrium separation between this R. Okay? This is say R1. For example, this is from R2. If you apply a force here, if there is a force here, external force, say mg. Mg is an external force on no? Then what will happen? There arises a force. What will happen here? R1 will become less than R2. So which forces will come? there will be a normal reaction. Understood this or not? Hello? On the other hand, if you take this configuration like this, and you have, this is R2 for example, you are applying a force like this, external force. Okay, then what will happen? Definitely there will be a force in this side. That force only is called as friction. Understood this? Because when you apply an external force, what happens? R2 will be greater than R0. Understood this? Just for a few seconds to think practically. Is it possible or not? See how your people are doing that much chemistry and all. This is all visible, simple logic, that's all. And you are getting marks in it, maths also. Physics is a practical one, everything, nothing is to be done. That is the mystery I am having. Unsolvable mystery. How people are getting 100 out of 100 in math when he is getting 40 to 45 in physics. What is the secret, man, Abra? If you tell, I'll try and explore methods how to make you to get marks. One is in the name of IIT paper, we can give a simple questions IIT. F is equal to MA, M is given, A is given, find them.
Learning the concept is important.
So you are not learning the concept of physics.
No, sir, we are learning, sir. I'm just telling that getting marks is not important. Just learning the concept is important. Our final exam.
For final exam, concepts are important. That time now you won't remember this formula. Any formulas or any theory you're mugging up without understanding. You won't remember because you'll be going into the exam hall under tension. So anything, memory will be volatile. It will be evaporated. When you have tension, you'll forget things. But logic you won't forget. Logic is permanent. Memory is temporary. So to first we should create logic. Why this happened, how this happened, when this happened. Right. Shall I turn this?
Yes, sir.
Huh?
Yes, sir.
That means if you observe this, both are contact forces. Contact means intermolecular forces. What is contact force? Intermolecular forces, no? So we can say whenever two surfaces are in contact, which forces will arise? Intermolecular forces will arise. These are called contact forces. That is what we say, contact forces. Okay. Now you have on a block only Mg acts on this, on a surface. Then you have only one contact force. What is that? Normal reaction. Why? Because it's pressing the surface now. Follow this? Hello? On the other hand, if this block is being pulled like this, then there will be another contact force. Clear?
Yes, sir.
Follow or not?
Yes, sir.
So that means I can say that contact force has two components. What is that? X component, horizontal component. Mean this act What is this called? It is called force of friction. Understood this? See, remember that force of friction will not act every time. This will act, this will arise only if the block has tendency to move parallel to surface. Do you agree with this? Then what is the other component it has, man?
Vertical component.
Acts perpendicular to surfaces in contact is called, what is this called?
Normal reaction.
Understood this? That means, remember that in summary, contact force is, one is, I can say that called Fx, that is nothing but friction. The other component is Fy, which is nothing but normal reaction. Okay, so now what is the net contact force? Is root over x component square plus y component square. That means friction square plus normal reaction square. Is it clear till here?
Yes, sir. Clear, sir.
Oh. So we have seen tension, we have seen normal reaction, we have seen what is friction. Is it clear?
Clear, sir.
Yes, sir.
Any difficulty anywhere you can ask. Don't hesitate.
In the previous page, can you please explain that force of friction statement once again, sir?
Which one?
That force of friction statement you wrote now, sir. It is an intermolecular force which opposes tendency of motion parallel to surface.
Yes, man. See, when you are trying to push this, the molecules are being pulled. When molecules are pulled, what happens? Intermolecular separation will increase. So there will be a force trying to bring back this original position, no?
Yes, sir.
That is why I have taken like this. What are this?
If the particle moves in a front direction, then the particle's intermolecular forces will move backward.
Yes, man. Observe that if you apply a force like that, R2 intermolecular separation increases. So molecules tries to come nearer, no?
Yes, sir.
Similarly, when you are pressing this by weight or something, you understand this. When you are pressing this R1 will decrease. When R1 decrease, what will happen? There will be force in this direction to restore.
Yes, sir.
Is it clear?
Yes, sir. Clear, sir.
Clear, sir.
Return this page.
1 minute. 1 minute.
1 minute. No.
चली चली रे पतंग मेरी चली रे, चली चली रे पतंग मेरी चली रे, चली बादलों के पार होके डोर पे सवार, सारी दुनिया ये देख देख चली रे, चली चली रे पतंग मेरी चली रे.
Hello?
Yes, sir.
Return this.
1 minute,
Just a
sir.
minute, sir. Just a minute, sir.
जो मस्त हवा में लहराए, जैसे उड़न खटोला उड़ा जाए.
See, today Friday evening 3:45 to 5:15. Any prayer is there?
No, sir. That evening prayer will be one there, sir. Evening prayer will be there, sir.
At 5:15, no?
At 4:30 or 4:30, sir.
4:30, sir.
4:30 to?
Sir,
10 minutes,
starting
it will
time
be
is starting time is for the prayer is 4:15, sir. We can offer it till 5:15, 5:30.
Because one fellow is asking today Friday and also change the timing we have prayer, Ames fellow. If this goes on like this forever, I cannot finish the syllabus. So next thing is I should keep classes in the night. And all students are not asking, only some students. I don't understand what is it. Actually for you, that's why I changed the timings. You used to have in the evening, remember?
Yes,
Yes,
sir.
sir.
Yes,
Only
sir.
on Friday you have that. Now if I leave at 5:30 to 4:30 for 10 minutes, I can take the class till 5:30, yeah?
You can take, sir.
Yes,
Yes,
sir.
you can take, sir.
Yes, sir.
Yes, sir, you can take, sir.
But those idiots are not training that. Again they want to get 5:15 some people. No, you just post me the timing, man. I'll seriously tell them.
Sir, actually, we can offer that prayer till 5:15, sir.
Yes, man. You just post the timings actually. I'll check up and but these idiots are escaping.
Yes, sir.
Some people are going to pray, they won't come. Okay, they won't come, I don't mind. The problem is they'll say that this is difficult, I don't like that. You put in sincere effort, anything you can do. People are going to Mars, man. Is it difficult? Physics is so difficult.
Sir.
No, only thing I can make easy is not to teach all these things directly, go to simple problem. Like these videos we have seen now. We'll just go to all things which are interesting and easy. Complicated things required for advanced, they won't. For that again, premium channel they will say, they have to pay lakhs of rupees for that. Anyhow, shall I turn this man over?
Sir, that F is the symbol of friction.
Yeah, the small f is symbol of friction. Yes.
Yes, sir.
Small letter f.
Completed, sir.
Right. So now we have seen force of friction and all. See, there is something called as the other force. Okay, this is a spring force. See, suppose this is spring. This is L naught. These are the two ends of the spring. Okay. So now you can see that L naught is called natural length of the spring. Means manufactured length. Spring, not string. Now you tie this one end. See this, when I am keeping these lines means this is non-movable. Whenever these lines are there, anywhere. What is the meaning of that? These lines indicate that it is non-movable and rigid, like a wall. Understood this? Or ceiling of room. like that. Many are there. I'm just saying. So you just keep that why they're keeping my things. Now I am taking some wall. I am tying this end. Now the natural length is now what I do is I apply a force here. Okay, this is external force. External force which causes elongation of spring. Do you agree with this? Say the elongation is, please understand it, this is actually L naught. Understood this or not?
Sir.
Now this end moves to this by x. Okay. Then again intermolecular forces, what does they do? They try to restore the length of the spring now.
Yes, sir. Yes, sir.
So this is what we call it as spring force. Okay. Understood this?
Yes, sir.
Understood, sir.
F. Clear? Now you can see that the same spring, suppose we are compressing it. This external force which causes, what does it do?
Pressure.
Then you can see there are forces in this direction. Okay, this is spring force.
Sir.
Follow this? See, from here to here you are compressing. Now you can see that we'll shortly prove that in a chapter called elasticity. Do understand that spring force has a magnitude equal to k times the elongation of the spring. Okay, this is x is elongation or compression produced in spring. Followed? And what is the direction of this? Spring force acts in which direction? Opposing compression or elongation. Do you agree with this? Therefore, we write like this. Force of spring is minus, will take k x bar. Alright. See, understood this? Here remember that k is called spring constant or stiffness constant. They'll give the value in the exam, don't worry. It's called spring constant. We'll prove all this shortly. Or what is the other name? Stiffness constant. Understood till here? Any doubt is there?
No doubts.
Understood, sir. No doubts.
So now I have just introduced to various forces. One is weight, that is due to force of attraction of the earth. The other one is normal reaction. The other one is tension. The other one is force of friction. The other one is spring force. Understood this? Now we come across these problems with these type of forces in all numerical. So every time what is spring force or is irritation for you and even for me. So I just explained you the different forces available. Understood this? Clear?
Yes, sir. Clear, sir.
Should I turn this?
1 minute, sir.
Till here you followed, all of you? Any doubts are there?
No, sir.
No doubt, sir.
Followed this?
Sir, but
Right then. You can go for your maths class.
Thank you, sir.
Right, take care. Bye.
Sir, there why we are writing minus k, sir?
Opposite. This minus sign indicates that opposite, no? Opposing, no?
Okay, sir, it is opposite to for fraction or elongation. That's why we are writing minus.
Yes. I can say that force of spring is opposite to x bar. That's why negative. Understood this?
Understood, sir.
Sir, if a body is falling, is under free fall, then it will have a force of mg, no, sir.
Only
There
mg,
won't be any reaction force, no, sir, opposing to it.
There won't be any reaction force for that. Reason is contact forces only will have reaction. See here, this is earth, no? This one body. Hello. This is mg, man. Then this will also act with this. This is the force. Suppose this is force. By Newton's law, even earth is also having the same force. This is force exerted by earth on the particle. By Newton's law, the same force should be exerted on the earth by particle, no?
Yes, sir.
Because, however, this mass is more, it won't move. This force is not sufficient. This mass is less, this force causes motion. Understood this? I apply 100 Newton force on a mountain. Mountain won't move, but I am applying 100 Newtons. Remember, force applied doesn't mean that it should move, no. Motion is depending upon velocity. Well, understood this or not?
Okay, sir, understood. Thank you.
We will continue tomorrow further, okay? Right then, take care. Bye.
bye.
Thank you, sir.
Excuse
Bye,
me,
sir.
sir.
Tell me.
Sir, I have a doubt. I will say you in 1 minute. Can you please wait? I'm searching it.
Okay.
Sir,
Hmm.
sir, yesterday you said that when two bodies are in contact, M1 and M2, the contact force will be in that case is 0. Sir, that normal force is equal to nullify the force.
There is
Sir,
no normal. Hello. There is no normal force only. See, this is one force.
sir.
Simply touching, there won't be any normal force. If you apply a force, this body tries to pull it, then normal motion will come.
Yes, sir.
If this is not there, there won't be. This is not trying to push that, no. When you're trying to push this body, and then intermolecular force will oppose that, no.
Yes, sir.
Sir, yes, sir. Yes, then that two intermolecular forces will be equal in magnitude, no?
Yes. This tries to push that also they'll push that. Intermolecular forces always will be same, no?
Yes, sir. Sir, but the two bodies' masses are different. That won't affect the intermolecular.
No, that won't depend. I'm telling you, masses are different, intermolecular forces are different. For example, you have so much cell structure that is DNA dependent, that you cannot change the basic structure of that, no? Other things are acquired. Other things are acquired. That you can change. DNA you cannot change, no?
Yes, sir.
Sir,
Tell.
sir, if we throw two balls with same velocity in vertical motion,
Okay.
one is of greater mass and one is of less mass, then which ball will reach the ground first, sir?
That depends upon air resistance, no? I have discussed this. If you consider air resistance, if air resistance is not there, that means there is no air resistance. Then both will reach at the same time.
Yes, sir.
But air resistance is there because other than mg, another force is coming. That is only air resistance. I have discussed that at length. Remember?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir. Understood.
Right. Take care then, okay?
Bye, sir.
Right. Bye.
Yes, sir. Bye.
Bye.